point-to-point path profile in microwave communications. Name: Myra Zhangyu Colaway. Course and year: BSECE 4. Subject: ALKS 402 E-Selective 1. Objectives: the main objective of this activity is to design a point-to-point path profile in microwave communications. The specific objectives include fixing endpoints, generating the terrain or elevation baseline, modeling Earth curvature and refraction, computing the Fresnel zone clearance, estimating antenna heights for line of sight, tabulating and visualizing the results, and finally, concluding the feasibility of the design path. Goal: the main goal of this activity is to design a microwave communication link that spans around 10 kilometers. I selected this location since it is located near my home, so this is from Tinampo, Ligao City, Albay as the receiver site, to Basag, Ligao City, Albay as the transmitter site. Materials and tools slide: Google Earth Pro. For marking coordinates, drawing the path, and generating the elevation profile. Google Maps to view nearby terrain and confirm actual site surroundings, Microsoft Excel. To calculate the Earth curvature, Fresnel zone radius, and antenna height adjustments needed for clear signal transmission. Procedures: 1. Site selection and zoning. For my transmitter site, I selected Basag, an upland area near Nosisi where I live, which provides higher elevation and better signal transmission. For my receiver site, I chose Tinampo near Kavasi, which is relatively flat and open, ideal for receiving microwave signals. Both are within Ligao City, and zoning restrictions in these rural areas are minimal, making them practical for antenna installation. 2. Coordinate identification. Using Google Earth Pro, I identified the exact coordinates. Transmitter: Basag, 1316 6.04 in, 123 35 43.80 e. Receiver: Tinampo, 1313 46.14 in, 123 30 40.1.480. These coordinates were then used as fixed endpoints to map the direct microwave link. Next, I used the Path tool in Google Earth Pro to draw a straight line between the transmitter and receiver. The total distance measured about 10.07 kilometers, representing the proposed microwave path. While enabling the Show Elevation Profile option, I generated a detailed cross-section of the terrain between the 2 points. From this, I observed that the elevation gradually rises from around 38 meters at Tinampo to 178 meters at Basag, showing a natural slope that helps maintain line of sight. Using Microsoft Excel, I calculated the Earth curvature bulge and the first Fresnel zone radius along different points of the 10 kilometers path. I used constants such as the Earth's radius 6,371 kilometers, effective radius factor K equals 4/3, and frequency equals 6 gigahertz. These calculations helped ensure that the line of sight path clears both the Earth's curvature and at least 60% of the Fresnel zone to prevent signal diffraction. Based on the curvature and terrain data, I estimated the antenna heights at both the transmitter and receiver sites. This ensured a clear line of sight with adequate Fresnel zone clearance for reliable communication. Using Google Maps and Google Earth Pro, I inspected both sites for physical obstructions like trees or buildings and took screenshots for documentation. All computed data, including elevation profiles, curvature effects, and antenna heights, were organized in Excel for clear presentation and analysis. In this video, I plotted the transmitter and receiver locations using Google Earth, then measured the path distance and created the elevation profile. Data and results. After showing the Google Maps locations and elevation profile data results in the procedures, I proceeded to compute the Earth Belgium, Earth Curvature Meter, Fresnel Radius Meter, Fresnel Clearance M, Total Height Extended Meter using Excel. This video shows how I performed the computations in Excel for D1, D2 Earth Curvature, Fresnel Radius, Fresnel Clearance, and Total Height Extended, and how I created the graph using Excel. And